This is a demo video on the implementations that take place in the i-CNC use case. The use case is developed under the open call of the TrialsNet project by CNC Solutions, University of Patras LMS, and Fogus Innovations and Services. Among the three CNC cutting technologies, drilling, lathing, and milling has been the go-to method for over 100 years. Its flexibility and precision make it ideal for creating parts from a wide range of materials. Despite its benefits, CNC milling faces a common issue called chatter. Chatter refers to an uncontrollable vibration between the cutting tool and workpiece, leading to poor surface quality and reduced component and tool lifespan. While traditional methods like adjusting tools or workpieces can help minimize chatter, these approaches are often manual and trial-based, falling short of the demands of today's high-performance machinery. The i-CNC use case belongs to the Industrial IoT with Cloudification category, as defined by ITU. The use case focuses on transforming the current CNC machining paradigm by addressing the chatter problem through an end-to-end solution that replaces traditional trial-and-error chatter supervision with a cloud-based and AI-enabled autonomous system. The key principles of the i-CNC use case are 5G connectivity, fast and reliable data transfer is ensured, AI-powered data analysis, AI models process and classify vibration signals from the CNC machines, cloud-based scalability, cloud services enable scalable use of more complex and efficient applications. Security and interoperability. Industry standards for secure data exchange are followed. Continuous data collection. Datasets are produced for long-term analysis. The setup of the i-CNC platform is as follows. A vibration sensor has been mounted on a CNC machine. A data acquisition system and a local processing unit collect the vibration signals. The signals digitalized and fragmented to network packets. The local processing unit feeds an operational assistant monitor, while at network level, it sends the produced packets to an industrial 5G router. Through a VPN connection and over a commercial 5G network, data are collected in a cloud infrastructure. The data are processed by an AI assessment unit, and the results are becoming available to the local processing system through an MQTT server. The required key performance indicators for the i-CNC use case include round-trip latency of up to 150 milliseconds, 4.9 service availability, as well as 90 to 95% accuracy of the AI application. The first set of end-to-end tests has been completed. The features validated during the tests are the industrial 5G routers with remote monitoring, the private cloud infrastructure with resource scaling capabilities, the VPN connections, and the MQTT server, as well as the initial implementation of the AI application. Indicative key performance indicators, KPIs, that were measured during the tests are 80 to 120 milliseconds round-trip delay at network layer, 180 to 300 milliseconds round-trip delay at application layer, as well as adequate user experience, given an unobservable time difference between the stimulus and the alert. Stay tuned for future videos from the i-CNC project.